This is a college algebra assignment for April 28th, Unit 4, Section 3, and also Unit 4, Section 4, Problems 1, 2, and 5. First thing we're doing is working with complex numbers. Remember, the square root of negative 1 is I. And then if you have I squared, it's negative 1. So, square root of negative 225 is the square root of negative 1 times square root of 225, 15i. Same thing on 4, break it down. Same thing on 6, break it down. You have your I. Then number 7 and 8. 8 is 9i to the 7th minus 5i to the 12th plus the square root of negative 18 minus 3i to the 4th plus 2i squared. I'm going to put in I squared as many times as I can. Like on 9i to the 7th, I put I squared to the 3rd power. That takes care of 6 of them, and then an I left over. Minus 5i squared to the 6th power gets everything on that one. Then break down square root of negative 18, square root of negative 1, square root of 9 and 2. Then I to the 4th is I squared squared. Then 2i squared. Every time there's an I squared, I put negative 1 in. The first one, negative 1 is cubed because I put it in there. Negative 1 cubed is negative 1, so this is negative 9i. Then negative 1 to the 6th, that's negative 1 6 times. That's positive 1 times negative 5, so negative 5. The next one, this is I, this is 3, so 3i square root of 2. Then this is negative 1 squared, which is 1, so negative 3. This is 2 times negative 1, so negative 2. Then I combine like terms. Number 10, we break down our fraction in this way. Break down that square root. Then make sure you cancel the same number in all the terms. In all the terms, you break down the same number. Then number 12, we add a plus b. A is 3 plus 2i from the given. B is 5 minus 7i. We add like terms. 14, C minus D. We put C in, put D in, and subtract. Remember, when you're subtracting, you change these two signs, and then combine like terms. 16, we multiply A times B using FOIL. Then we simplify, remembering that I squared is negative 1. So it's negative 14 times negative 1 through these steps. 17, okay, 18 is a fraction. 3 plus 2i over 5 plus I. We need to get rid of that radical in the denominator. So we multiply by the conjugate of 5 plus I. 5 minus I over 5 minus I. Taken times this. Then we use FOIL. Work it out with FOIL. Remember, I squared is negative 1. So that's going to allow us to simplify. And we get this answer. 20, we add A, B, and C together, just like I've shown here. Just like I've shown here. Add those things together. I get 5 minus 7i over 5 plus I. Again, we need to get rid of the radical in the denominator, which is the I, so we multiply by the conjugate. Again, we use FOIL, as we've done here. Notice on the bottom, when you're using FOIL, the middle two terms cancel out. Then, of course, I put negative 1 in for the I squared, and I get this. Then I have 18 minus 40i over 26, reduced by taking 2 into every term. Solving equations, number 22. Just go straight to your quadratic formula. We get the square root of negative 100. So that's 10i, remember. 24, quadratic formula again. Go through the quadratic formula and we get down to here. Remember to cancel your 4's. 25 is like 26. 26 is, we've got an x to the 4th in our equation. It's a polynomial like we've been doing on the previous assignment. So we're going to have to go through the rules. We've got 4 sign changes, so I've got 4 positive roots. I put the 10 over the 1, find the factors of 10 over the 1 factors, and that gives me the possible roots, which are 1, 2, 5, and 10. So I try 1, it is a root. I'm left with these numbers. Normally I'd try 1 again with these numbers, but I went to 2. Then on that 2 I found it was also a root. 1 and 2. This 1, 2, and 5 means 1x squared plus 2x plus 5 that I put in the quadratic formula, and I find my solutions. 27 is just like 26. 27 is just like 26. 28 can be done with the square root theorem because there's only one variable in the equation and it's in something squared. So I get that by itself equal to the negative 16. I take the square root of both sides. So x minus 3 equals plus or minus 4i from that negative 16, square root of negative 16. Move the 3 to the other side. So that's the easiest way to solve 28. Then on 1, 2, and 5 here, we're going to be graphing. Now number 1 is something we've done before. Factor it, and that'll give you your x-intercepts. But number 2 is not factorable. So I went through all of these steps here, just like we've been doing with our questions here. Normally, an x cubed graph is going to look like this and down here, or this and here. That's kind of their normal look. Now, I go through this. I find my sign changes. Okay, 1, 2, 3. So all of my roots are positive. I put the 15 over 1. Here's my possible numbers. I go through here. I find 1 is a root. So 1 is a root, and so that means it's an x-intercept. Then I have x squared minus 8x plus 15 left equal to 0. I factor it, and x minus 5, x minus 3. So 3 and 5 are also x-intercepts. My y-intercept, put 0 in for the x, give you negative 15. Then, either with the table or by hand, find some other values, as I did here. And it's helpful to find values in between your x's, and maybe to the right of your x and to the left of your x, as I've done. But I found these points, and I get this graph here. Okay. Then, number 5 is a rational expression, is what we call it. X plus 2 over x minus 2. This is going to have 2 what we call asymptotes, as I show right here what they are. But here's how you find them. First, you find your domain. X is everything but 2, because you can't have a 2 down there. You'd be dividing by 0. So that's the first thing you do. Draw a vertical line at x equals 2. That means our graph cannot cross it. Cannot cross it. Then we go to our range. The range is, okay, it's going to be this horizontal line here. It is found by putting whatever your x is on top, which is x only, over whatever x term you have in the bottom, which is x. X over x is 1. And interestingly enough, that is what we have. Your range is all the y-coordinates except 1. So we draw y equals 1, we draw x equals 2. So on my graph down here, that's the first thing I draw is my asymptotes. X equals 2, y equals 1. Then I find my x-intercept. Your x-intercept is by putting 0 equal to your numerator. So x equals negative 2. So negative 2, 0 is your x-intercept. Then you put 0 in for all the x's. 0 in for all your x's is 0 plus 2 over 0 minus 2, negative 1. So that's my y-intercept. Then that tells me what my graph is going to do on this side of the vertical asymptote. Your graph is between here and here. That means it's going down here, and it's going to go along that vertical asymptote but never cross it. Here it's going up towards that horizontal asymptote, but it will never cross it. Now what we need to do is find out what it does on the other side of the vertical asymptote. So I put in points like 3 and 4. Put them in to my original equation way back at the beginning, x plus 2 over x minus 2. 3 and 5. 3 gives me 5, and 3 and 4 is what I put in there. 3 and 4 in there gives me 5 with the 3, and 3 with the x is 4. So I have this part of my graph here, meaning to the right it goes along the horizontal asymptote, and right next to the vertical asymptote it's going towards infinity. This is what a rational expression graph looks like.